Hello, everyone. Welcome back. Today, we're going to find the asymptotes of a function. Actually, in fact, we're going to find the asymptotes of these three functions here. But first, I want to just talk about the criteria for what is or isn't an asymptote. So, how do we know if there's any vertical asymptotes in the function? Basically, anything that's a zero of the denominator but not a zero in the numerator would be considered a vertical asymptote. And the reason that it's important that we check the numerator as well to make sure it's not a zero in the numerator too is because if we have the same zero in the numerator and in the denominator, that means that we would be able to cancel out those factors and we'd actually have a whole rather than an asymptote in that situation. Then, as for the horizontal asymptotes, we have to look at the degree of the numerator and the degree of the denominator. And if the degree of the numerator and the degree of the denominator are equal, that means we use the leading coefficient over leading coefficient to get the answer. If the degree of the numerator is greater, however, there's no horizontal asymptote. And if the degree of the denominator is greater, then the horizontal asymptote, is at zero. Okay, so let's apply this knowledge to state all of the asymptotes here. So let's start with the vertical asymptotes. So the potential vertical asymptotes based on the denominator here would be x equals to -2, x equals -1, and x equals 5. But we do have to check, are there any of these terms, or are there any of these factors rather, that would cancel out? Well, yes. X plus 2 and x plus 2 cancel out, and that means that at x is equal to -2, there is a hole. So there's a hole at x equals -2, which means it's not also a vertical asymptote there. The vertical asymptotes are at x equals to -1 and x equals to +5. Okay, now what about the horizontal asymptote? So for horizontal asymptotes, there can actually only be one for each function. Not all functions have one, but the maximum there can be is one. Whereas for vertical asymptotes, the maximum there can be is equal to the degree of the denominator, but there could also be less as well, depending on the circumstances. So for horizontal asymptotes, we need to look at the degree of the numerator and degree of the denominator. Well, the numerator has a degree of 3, because if we were to expand this, we would get 5x cubed and then plus a bunch of other things as well. And then in the denominator, if we were to expand the denominator, we would get 7x cubed and then plus a bunch of other stuff that is not the leading term, so we don't care about it for this purpose. So the horizontal asymptote in this case is y is equal to 5 over 7, because it falls into this second case here, where if the degree of the numerator and degree of the denominator are equal, then we just need to look at the leading coefficients, and that's going to lead us to the horizontal asymptote. So therefore, there are 3 asymptotes in part A. For vertical asymptotes, their x is equal to -1 and x is equal to 5. And for horizontal asymptotes, there's just the one, and it's 5 over 7. Okay, let's look at this next equation. So let's start with the vertical asymptotes. Well, the vertical asymptotes are the same as the zeros of the denominator. The zeros of the denominator are -2 and 3, and none of them are also zeros of the numerator, so none of them are actually wholes rather than a vertical asymptote, and so both of these are good to go there. As for the horizontal asymptote, well, in this case, the degree of the numerator is just degree 1. It's a linear numerator. And then the degree of the denominator is a quadratic. If we were to multiply x plus 2 by x minus 3, we'd get x squared and then, plus other things as well. But we'd have x squared as the point, which means that we would have a degree 2 in our denominator. And so what does that mean? What if the degree of the numerator is less than the degree of the denominator? Because here we have degree 1, and here we have degree 2. So therefore, the degree of the numerator is less than the degree of the denominator. That means that there is a horizontal asymptote, and it's at y is equal to 0. So there we go. All right, one last one. For vertical asymptotes for this one, again, we need to just check the denominator and see what the zeros are and just make sure none of those zeros are also zeros of the numerator. In this case, the only zero in the denominator is -1, and that is not a zero in the numerator. It's not repeated there, and so we're good to go there. As for horizontal asymptotes, In this case, the degree of the numerator is degree 3. If we were to expand this, we'd get x cubed. And then for the denominator, we just have degree 1. And so therefore, the horizontal asymptote is that there is none. There are no horizontal asymptotes because when the degree of the numerator is larger than the degree of the denominator, which it is in this case, that tells us that there are no horizontal asymptotes. As always, feel free to leave any questions in the comment section, and we'll see you for the next one.